The summer air over Paris was trembling with heat. Charles de Gaulle breathed in a familiar rhythm. Continuous announcements, the hum of jet engines, the smell of kerosene, hot concrete, and the endless movement of people. This airport lived like a separate organism, strict, noisy, organized. But there was something more than just a departure schedule in every sound. Half the world's routes intersected here, and every day tens of thousands of people dissolved into its corridors, like particles of a huge mechanism. Overhead walkways vibrated with footsteps, tractors slowly crawled along the apron, and mechanics in orange vests swapped places with crews heading for their planes. Passengers looked at their watches. Someone was in a hurry. Someone looked at the liners for the first time in their lives and froze. All these were regular, predictable flights, Airbus, Boeing, regional cars. This whole aerial routine functioned like a huge clockwork. But that day, among the hundreds of standard sides, there was one whose silhouette could not be mistaken for anything else. Long, elongated, with a thin delta wing and a nose bent to the ground, Concorde looked as if it had come here by accident, as a guest from another time. Against the background of heavy, wide passenger planes, it looked like lightning frozen over a concrete strip. The machinery around him was moving slower. It was an unofficial rule of the airport. There was no rush next to this liner. Not because you can't, but because no one wanted to break the magic of the moment. Even the experienced staff carefully looked along its hull, as if checking to see if it really existed. The Air France 4590 was preparing for the flight in the familiar silence of the pre-flight rush. The shadows of the crew members moved in the cockpit methodically and confidently. They studied telemetry, checked engine parameters, checked hydraulic pressure, and the condition of the fuel circuits. Everything is strictly according to procedures, step by step. And yet it felt different. Concorde did not give the opportunity to relax. Its systems were complex, and the Olympus 593 engine required precision almost like a spaceship reactor. Any number had to match the checklist perfectly, down to the last unit. On the apron, the sound from its onboard units was drier, louder, and seemed to be denser than that of conventional aircraft. It was as if the metal itself was holding the tension. Passengers who passed through the glass galleries stopped for a second to look. Even if they had seen the Concorde before, it evoked the same feeling every time. A rare, almost childlike admiration. The airport was living its double life at that moment. On the one hand, there is the usual flow of people, suitcases, queues, negotiations between pilots and dispatchers. On the other hand, there was the invisible electricity that appeared every time Concorde started preparing for takeoff. And although no one knew yet that something irreversible would happen on this day, the atmosphere was saturated with a light, almost cinematic tension. Not with anxiety, but with expectation. It was as if everyone intuitively understood that the takeoff of a supersonic airliner is always an event, even if it happens every day. Against the background of the steady hum of the airfield, among dozens of voices on the air, one dispatcher noticed Concorde with a glance as soon as he appeared at the taxiing area. Reflexively, habit, this white triangular silhouette always stood out from the rest, like an arrow ready to pierce the sky. It is at this point in the narrative that a subtle but important contrast occurs: ordinariness versus exclusivity. Everything continues to live according to schedule, but the eye is focused only on one car, the one that always evoked a mixture of respect and awe, to a plane that was faster than sound. Among the hundreds of wings warming up their engines, only one thing evoked the same feeling in people: a whisper of admiration that could not be drowned out either by the volume of the airport or the familiarity of daily work. When Concorde emerged into the light of concrete, it seemed to destroy the usual logic of civil aviation. In a world where everything was measured at a speed of 800 to 900 kilometers per hour and a height of 10 to 12 kilometers, this liner lived by different laws. The speed at which it could cut through the air exceeded two speeds of sound, about 2,180 kilometers per hour. This is more than the Earth's rotation speed at the equator. So fast that time became malleable. You fly out in the evening, and after 3.5 hours you watch another sunset on the other side of the ocean. At an altitude of 18 kilometers, the sky was changing color. It was getting darker, denser, closer to space. Through the portholes, the outline of the planet was visible, a slight arc of the horizon, the same curvature that is rarely seen even on high mountain peaks. Passengers said that it felt like you were flying over the world, rather than through it. Concorde literally lifted people to a place where only military interceptors flew. But there was another contrast here. The civilian airliner competed in performance with combat aircraft. For example, the popular F-18 Hornet fighter, a fourth-generation machine, reached speeds of about Mach 1.8, which is equivalent to about 1,900 kilometers per hour. This is impressive for a combat aircraft, but even it was inferior to Concorde. He flew faster, higher, and did it for hours, maintaining the stability and accuracy of the route. To withstand such loads, its design was as unusual as possible. The thin delta wing made it possible to maintain lift at supersonic speeds. This wing worked differently from the usual straight or swept wings of conventional airliners. It did not require complex mechanical flaps for maneuvers. Instead, the delta-shaped aerodynamics created vortex flows that kept the airliner in the air even at critical angles of attack. This solution was both beautiful and functional minimalism with the engineering precision of surgery. Concorde's movable nose has become a separate legend. During takeoff and landing, pilots needed forward visibility, and because of the high cockpit and the large pitch angle, the nose blocked the view. Therefore, it could go down like a helmet visor. After takeoff, the mechanism lifted it back up, and the plane acquired that most recognizable shape: long, predatory, streamlined. At supersonic speeds, every millimeter of the contours mattered. The temperature of the skin at a speed of 2 Mach exceeded 120 degrees. The aluminum expanded, and the plane became 20 to 25 centimeters longer. It wasn't a mistake. The engineers had planned this effect in advance. There was a separate instrument in the cabin, an indicator of the skin temperature. If its values approached critical, the crew reduced the speed to a subsonic in order not to overload the structure. It was an ever-changing struggle. The air that is trying to rip apart the plane, and the machine that must defeat this air. Each of the 4 Rolls-Royce/Snecma Olympus 593 turbojet engines developed thrust of up to 17.5 tons during afterburner. They consumed from 7 to 15 liters of fuel per second, a figure that is difficult to imagine. For comparison, the average car consumes about 6 liters per 100 kilometers. Concorde spent such a rate in an instant, but it was precisely this appetite that made it possible to maintain the very speed that no civilian aircraft had ever achieved. Paradoxically, for all its technological rapacity, Concorde was also a symbol of luxury. Politicians, musicians, athletes, and people for whom time was more valuable than money flew on its boards. Princess Diana, Mick Jagger, Phil Collins, Chirac are legends and leaders who have cut across the Atlantic faster than you can watch a movie. A Concorde ticket cost the equivalent of more than $20,000 today. It wasn't just a journey, it was a statement. You're one of those people who can afford to fly faster than sound. People describe this flight the same way. Not the luxury of the cabin, not the service, not the champagne. The main feeling is incredible speed. Her body felt different, as if time was vibrating nearby. Many passengers said that no matter how many times you flew, this plane always left a feeling of unreality. But in every legend, there is something that is usually not talked about. The price of progress, weak structural elements, details that have been hiding for decades in the shadow of beauty and speed. Technology is never perfect, and even the most advanced machines have points where the line between stable operation and critical operation becomes too thin. But every miracle has a shadow side, the price, weaknesses, risks that no one thought about. The main irony of supersonic was that its weaknesses were not where they were usually found. Not in engines that could withstand 2 speeds of sound. Not in a wing capable of holding an airliner at the height of military aircraft. And it wasn't even the temperature of the cladding, which heated the metal to 120 degrees. The real vulnerability lay much closer to the ground, in details that seemed too trivial to be a threat. One of these elements was tires. On the Concorde, these were the busiest wheels in civil aviation. The pressure in them reached about 20 atmospheres, which is much higher than that of ordinary passenger liners. The reason is simple. To break away from the lane at a speed of about 350 km/h, the wheels had to withstand tremendous loads. 1 gram of rubber flying out of a tire at that speed could have the energy of a small hammer blow. It was a physical limit that engineers had been putting up with for decades, realizing, this is the payment for supersonic sound. In aviation, there is a key moment that determines the fate of any takeoff, the V1 speed. This is the boundary, the crossing of which makes it impossible to interrupt the run-up. Before V1, the commander can stop the aircraft. After that, he is obliged to continue taking off even if something went wrong. On Concorde, this speed was higher than that of most airliners, about 280 kilometers per hour. And the higher the V1 speed, the less time is left to react. There are only a few seconds between everything is fine and there is no way back. A few seconds that will be crucial that day. On the surface of the airfield, it looked simple. A snow-white plane enters the runway, the crew clarifies the parameters, and the dispatcher gives permission. But there are much more difficulties inside the cabin. The Concorde crew couldn't just turn on the engines and take off. For them, every element mattered: air temperature, pressure, side weight, fuel configuration in the tanks, the operation of each hydraulic line. The system was so sensitive that a change in the outside temperature by several degrees could affect the takeoff parameters. On that July day, the heat was intense, about plus 31 degrees Celsius. It was a warm summer evening for the passengers. For a supersonic airliner, this is a complicating factor. Hot air is less dense, which means it requires more thrust and a longer takeoff run. Concorde could handle it, but the limits were palpable. The pilots knew that everything should work perfectly under such conditions. The crew of Flight 4590 was experienced. Commander Christian Marty had more than 13,000 flight hours. The co-pilot Jean Marco is over 10,000. Flight engineer Gilles Jardineau, more than 12,000. These were people who were used to driving an ultra-precise machine that did not forgive negligence. They checked every number, checked all the parameters, and found nothing that went beyond the norm. Routine, calm, confident preparation. But the hidden tension was already in the air, technical, imperceptible, mathematical. It's the same when the huge mechanism of global aviation works perfectly, but one small element can change everything. At that moment, no one thought that their runway was hiding a detail that did not relate to Concorde, did not relate to Air France, and did not even relate to their crew. A small detail, only 43 centimeters long, will become the point of no return, not in the air, but on concrete. 1630. Nothing foreshadowed trouble, but already at that moment, the fate of Flight 4590 was decided. on Earth. The snow-white Concorde slowly rolled out onto the taxiway, moving almost silently compared to what it would become in a few minutes. It was a familiar ritual for the crew. Smooth low-thrust acceleration, list checks, and short dialogues with the dispatcher. Nothing superfluous. Everything is strictly within the procedure. Taxiing took place along a familiar route to the 26R lane, one of the longest in all of Europe. Concorde took off most often on this concrete highway. Ideal length, smooth surface, convenient exit to the course. Every meter was important here, especially on a hot day when the air temperature ate up some of the lift. The crew took this into account. They adjusted fuel consumption, checked engine operation at elevated modes, and clarified the estimated takeoff distance. The attention in the control room was also growing. Every Concorde flight turned a normal working day into a more stressful one. Even the experienced controllers couldn't help but watch it a little longer than the other planes. His takeoff was not just an item on the schedule. It was the moment when the entire airfield system had to work perfectly. But no one knew that perfection had already been violated. A few minutes ago, in front of Concorde, a McDonnell Douglas DC-10 from Continental took off from the same runway. A large, bulky wide-body liner. During its run up, a narrow titanium element 43 centimeters long, an overlay that covered one of the reversing units, came off the engine. The element was torn off by the aerodynamic flow, and it fell onto the runway. It happened a few dozen meters from the place where the Concorde was supposed to accelerate. Titanium is a rare material, very light but incredibly durable. It is used where ordinary aluminum bends and steel weighs too much. And that's why such a fragment was more dangerous than any stone or metal debris. At the speed of a regular airliner, he could leave a trail. At Concorde speed, turn into a destructive wedge. But the crew did not see it. Dispatchers too. The runway monitoring system could not detect the fallen fragment in real time. The titanium lay on the strip like a slow, acting ample, unnoticeable, alien, but perfectly positioned to become the starting point of the disaster. Concorde, meanwhile, took the executive lead. Against the background of the uniform hum of the airport, its engines began to gain power, at first smoothly, almost soundlessly. Then the sound abruptly became denser, heavier. The Olympus 593 engines entered a mode in which each revolution created a powerful airflow, and the entire aircraft vibrated slightly. That's how he woke up before takeoff. The dispatcher gave permission for the launch. The crew answered calmly and confidently. There was not a shadow of doubt in their voices. They've checked everything. All systems were working normally, but it was impossible to see the hidden threat outside the cabin. To understand its scale, it is enough to imagine physics. An airplane weighing about 180 tons accelerates along a concrete strip to a speed of almost 300 km/h. The wheels rotate at over 2,000 revolutions per minute. The pressure in the tires is higher than in the fire hose. And in order for all this to continue to work, the surface under them must be perfectly clean. She wasn't like that day. Concorde began its run-up. The liner accelerated rapidly. I passed the 100 km/h mark, then 150, 200. Mass and speed merged into one continuous movement. And ahead is the point where the DC-10 left its mark. And when Concorde accelerated to almost 300, it happened. As the Concorde speed needle neared the mark where only a few seconds remained before the point of no return, there was something under its left main landing gear that should not have ended up on the runway of the country's largest airport. The titanium plate, narrow, only 43 centimeters long, weighing less than a kilogram, is an alien fragment left by an airplane that took off a few minutes earlier. The Concorde wheels were huge, designed for extreme loads. But even they had a limit. When the left wheel hit the titanium element, the impact was instantaneous. At a speed of about 320 kilometers per hour, the tire burst with a force that is difficult to imagine. The energy contained in this explosive rupture is comparable to the impact of a massive metal object accelerated to hundreds of meters per second. A fragment weighing about 4.5 to 5 kilograms separated from the tire. Its speed was estimated to be about 140 meters per second, almost half the speed of a screw bullet. But the main thing is the direction. The fragment flew up, straight into the root of the wing. That's where fuel tank number 5 was located. There were no thick armor plates on the lower part of the Concorde wing. The design was designed for aerodynamic efficiency rather than hitting a solid object. When the tire fragment hit the skin, something happened that the engineers theoretically allowed, but did not consider a realistic embodiment. The metal was pierced like foil. The following is the physics of a liquid under pressure. Inside the tank, the fuel was in conditions where the pressure did not allow it to stand still. When the skin cracked, a small but critical gap was formed. A powerful stream of kerosene burst out through it. Not drops, but a stream. It was as if someone had opened a fire hydrant inside the wing. This flow met with the hot elements of the propulsion group. Contact was enough, and a flame appeared instantly. Not a flash, not a torch, but a whole sheet of fire that stretched behind the wing like the tail of a comet. The temperature became so high in seconds that even experienced observers on Earth realized that this was no ordinary depressurization. In the cockpit, the crew had not yet seen visual fire. The Concorde had narrow windows, and it was impossible to look back. But the sensors have already detected anomalies. Engine number 2 started to lose parameters. The left wing, which was supposed to provide lift, became overloaded with thermal and aerodynamic asymmetry. The dispatcher's voice broke into the broadcast. He spoke quickly, loudly, almost on the verge of screaming, and this was not part of the procedure. Concorde 4590, you have flames behind you. I repeat, you have the flame behind you. These words meant one thing to the crew: urgently confirm the problem and turn off the engine. The commander immediately gave the command to stop the engine. Point 2. The flight engineer activated the fire extinguishing system. All the procedures were performed perfectly, without pauses, without panic, as in training. But the situation has already gone beyond the training scenarios. The tire rupture damaged the chassis cleaning mechanisms. The left rack jammed and remained released. This created a huge aerodynamic drag. The plane accelerated, but the drag became so high that it was more difficult for it to gain the necessary forward speed for a confident takeoff. The dispatcher got in touch again, not formally, but almost with desperation. 4590, the landing gear is not retracting. Act on your own. You have priority for a refund. But a refund was not possible. Concorde was already behind V1, the point at which stopping the takeoff is more physically dangerous than continuing takeoff. The remaining strip length was too short. Ahead are buildings, machinery, and cargo terminals. An attempt to slow down would lead to a catastrophic rollout. The crew did not discuss it. He knew the rules. At such moments, there is no philosophy in the cockpit, only mathematics. The commander said, "Speed, speed, the speed." These words are not a request, not an alarm. It's concentration. Takeoff must be continued despite the fire, engine failure, escaped fuel, unstable speed, and lack of thrust on the left side. They did everything possible to lift the airliner off the ground and try to reach Le Bourget airfield, the nearest accessible point. But the worst thing is not the fire, and the fact that the crew could no longer stop the takeoff. When Concorde finally broke away from the runway, it was no longer a takeoff. It was an effort contrary to physics. The airliner rose heavily, as if every second in the air was given to him at a huge cost. The left wing contour was on fire, the thrust on the two engines was falling, and the jammed landing gear was pulling the car down, creating resistance comparable to an open parachute. In the cockpit, the crew saw only numbers and instrument sounds. The fire from behind was invisible to them. The screaming dispatcher was the only source of external information. They did not know the scale of the disaster, but they understood perfectly well from the testimony. The thrust drops, the port side loses its symmetry, and the airspeed is kept within critical limits. And they continued the procedure anyway, strictly, precisely, without loss of concentration. Engine number 2 was already turned off and fixed by the fire extinguishing system. But after a few seconds, engine number 1 began to fail. There were interruptions on it, the pressure and temperature parameters became unstable. This meant one thing: the port side was almost completely devoid of thrust. For a supersonic airliner built on aerodynamic symmetry, this was deadly dangerous. Any drop in thrust on one side caused a torque that was increasingly difficult to compensate for. The commander continued to hold the plane, working the steering wheel and pedals almost to the limit. At such moments, the cabin turned into a place of silence, not because nothing was happening, but because every millimeter of movement had to be adjusted. The crew members had a professional memory. Dozens of hours of training, hundreds of simulations, thousands of procedures. But one problem was insurmountable: the chassis. The jammed left rack remained fully released. It worked like an air brake. The speed dropped at times when it had to be maintained at all costs. For Concorde, the minimum safe speed after takeoff was high. This is not an ordinary airliner, which only needs to gain 15 to 20 meters per second. Concorde required dynamics, but there was no dynamics. The commander realized that the only chance was to try to reach Le Bourget airfield. This was the nearest area where an emergency landing could be performed. The distance is only a few kilometers. For an ordinary airplane, this is nothing. For Concorde in this state, it is an almost unattainable goal. The liner was rising slowly, very slowly. The climb took place as if an invisible hand was holding him by the tail. The instruments showed about 60 meters. This is an altitude that does not give a single chance to maneuver. At this altitude, any fluctuations in the course require a masterly reaction, because there is no room for error. From below, residential buildings, roads, infrastructure. Above is the sky, into which the plane was trying to break through with all its might. The crew heard warnings from the systems, red lights, signals about a drop in thrust, loss of control of the port side. But no one uttered the phrase "impossible." This is a rare moment in aviation. When people continue to fight, even though the plane is doing everything to crash down. On Earth, the observers saw a completely different picture. Concorde flew low with a big roll, leaving behind a long tail of fire. The car looked not like an airplane in climb, but like an object that is trying to stay on the trajectory despite aerodynamics. His left wing seemed to be heavier than his right. The flames and destruction had changed the centers of mass. But there is silence and concentration in the cabin. The commander said again, "Le Bourget. We're trying to make it." There was no panic, no screaming, no emotional breakdown, just a task, even when the probability of success began to tend to zero. And yet they fought to the end. In the last seconds of its flight, Concorde didn't look like an airplane. It looked like a wounded arrow struggling to stay in the air. The left side was losing aerodynamics, the thrust on the two engines was almost zero, and every attempt to straighten the course required efforts from the crew that could not change the physics of what was happening. From the ground, it seemed that the liner was moving too slowly, as if it was being pulled down by an invisible weight. It barely passed over the roofs of houses, touching streets and courtyards with its noise and fiery plume. People on the ground, not understanding what was happening, raised their heads, first in surprise, then in horror, realizing that the plane was flying too low and too unstable. His path ended at a traffic junction near the small town of Gons. It was here that the Hotelissima Hotel stood, an ordinary 3-story building designed for those who came to the airport for early flights. At that moment, there were several guests and employees inside, none of whom expected that in seconds a mass of metal, fuel, and fire would fall on them. When Concorde touched the top of the building, the impact was instantaneous. The plane destroyed a corner of the hotel like a map made of thin walls, and then crashed to the ground, leaving behind a flash that shook even the air. The explosion was so powerful that drivers on nearby roads instinctively covered their faces with their hands, and windows in nearby houses shook. The flames rose tens of meters. A fiery cloud enveloped everything around: the parking lot, part of the building, and the trees nearby. The kerosene that spilled over the ground formed a seething lake of fire, and the heat was such that it was impossible to stand close to it. Seconds turned into chaos. People were running out of the hotel, passengers on nearby roads were slowing down, and locals were running out into the street to figure out what had happened. The first eyewitnesses took out their phones and cameras. The shooting was shaky, unfocused, not because the technique was bad, but because no one could believe in the reality of what they were seeing. The footage showed fire trucks trying to approach the fire, but the temperature was so high that the wreck looked like a giant furnace. There was thick black smoke over the entire area, which disappeared into the warm summer air. Rescue services arrived almost immediately. The sounds of sirens drowned out the noise of burning fuel. Firefighters were laying water supply lines, and ambulance crews were trying to find those who might need help. But the scale of the destruction was dramatic. The plane was completely destroyed, the area around it was flooded with fire, and the hotel itself partially collapsed. To the people nearby, it was like a scene you would never expect to see in reality. They said that the smell of burning fuel could be felt several hundred meters away, and the heat could be felt even behind the backs of the cars. No one could have imagined that something like this had happened to a supersonic airliner, which was considered the pinnacle of engineering. In the news agencies, the first messages sounded in a matter of minutes. At first, these were short phrases about an emergency situation, then clarifications that the plane crashed after takeoff. In the television studios, the presenters spoke with pauses because the information was so unexpected that they had to double-check it 10 times in a row. The Concorde, a symbol of speed, stability, and prestige, disappeared in seconds. It was a blow that the whole of France heard. Why did everything happen? And was it possible to save the plane? When the first emotions subsided and the flames at the crash site were finally extinguished, the work of those who have no right to make mistakes began. The French Bureau of Investigation of Aviation Events, BAE, took control of the case. Their task was not to find the culprits. It's about reconstructing the chain of events to the last second and understanding how the supersonic airliner ended up on the ground a minute after takeoff. The investigators had to disassemble the disaster the same way engineers disassemble a mechanism, piece by piece. Thousands of fragments of the aircraft, structural fragments, landing gear parts, destroyed wing elements, and tire remnants were collected in the charred area. It all came together like a jigsaw puzzle, where every piece has meaning, even if at first glance it looks like a meaningless scrap of metal. The first doubts disappeared when the experts found the very fragment of the tire massive, weighing about 5 kilograms, with characteristic traces of impact on a solid object. And soon, the object itself, a narrow titanium lining 43 centimeters long, lay on the runway just a few hundred meters from the start of the run. Its shape and damage matched the model of the DC-10 Continental that took off just before Concorde. Titanium is an ideal weapon material, lightweight but durable. This combination makes him dangerous when he is lying on a concrete strip along which a 180-ton aircraft is rushing. For an ordinary airliner, such a fragment would be a threat. For Concorde, it is a deadly factor, and all because of one number: speed. At the time of impact, the wheels accelerated to about 320 kilometers per hour. The tire pressure was about 20 atmospheres, one of the highest values in civil aviation. These tires were created specifically for supersonic airliners, but even they had a physical limit. At speeds where the rotation of the wheel reaches 2,000 revolutions per minute, contact with a solid object turns the tire into a source of destructive energy. The breakup happened instantly. The fragment penetrated the skin in the area of the fuel tank number 5. And this became the key link in the whole tragedy. It was the breakdown, and not the tire rupture itself, that created a situation for which the plane was not ready. BA carefully simulated what was happening inside the tank. There was more than just fuel there. It was pressurized and distributed into sections to ensure the correct centering balance of the aircraft at different speeds. When a crack formed, the fuel rushed out in a flow comparable to the discharge from a high-pressure pump. This explained the huge fire trail that the eyewitnesses had seen. Next, the investigators studied the chronology of the crew's actions, and it has become one of the most important elements of the investigation. The data from the voice recorder and instruments showed that the crew acted perfectly. Not just right, but perfect. The commander did not try to stop the takeoff because he was already over V1 speed. After this mark, braking becomes a much more dangerous threat than continuing takeoff. The plane could roll out of the runway and collapse before attempting to climb. Every pilot knows this rule, and the crew strictly followed it. The flight engineer immediately turned off engine number 2 and activated the fire extinguishing system. The co-pilot monitored the speed, saved the parameters, and tried to maintain course in conditions of asymmetric thrust. Not a single wrong decision was made in the cockpit. The BEA has determined that the human factor is excluded. When the experts finished reconstructing the events, they saw a picture where everything came down to one small element that fell from another plane. No mistake by the crew, no design flaw in Concorde could have led to such a scenario without an external object on the runway. The tragedy was the result of a chain of events that began long before Concorde began its run-up. But after the answers, a new question arose: what should I do now? When the BAE completed the main phase of the investigation, not only France, but the entire global aviation industry was in front of the mirror. The disaster turned into a point where, for the first time in many years, major aviation authorities and engineers began talking not only about the rules, but also about the possibilities to change the very foundations of safety. Technological progress is always born where the system is facing its limits. One of the first areas of discussion was the runway. The EMAS technology, the engineered materials arresting system, existed in the world. These are special areas outside the runway filled with brittle material that collapses under the weight of the aircraft, creating controlled braking. In the United States, such systems have long been used to prevent rollouts. But in Europe, they were introduced slowly. It was believed that long stripes were enough. The Concorde tragedy showed that sometimes a few meters are not enough to save an entire plane. The proposal to lengthen the bands and install EMAS began to sound especially loud. The simulation showed that in conditions of a hot day and high speeds, even a small section of the EMAS could give the crew a chance to stop at the end of the lane without coming into conflict with buildings and roads. Parachute systems have become another direction. Not those used for ejection, but large ballistic parachutes capable of stabilizing an entire aircraft. On civilian airliners, this idea seemed almost fantastic, until the engineers remembered real examples. The American Cirrus Vision jet, a compact business jet, was already equipped with the CAPS Cirrus airframe parachute system. This is a huge parachute that can be activated directly from the cockpit. After opening, the parachute keeps the aircraft in a controlled descent. In practice, there are dozens of cases when such a system saved the lives of crews in case of engine failures, loss of control, and other critical situations. The engineers discussed, what if a similar system were scaled for heavy aircraft? Are there any materials that can withstand a shock pulse when opened? Is it possible to distribute the load on the fuselage so that it does not collapse? The answers were difficult, but for the first time, the idea itself turned out not to be a theory, but a direction worth exploring. Some experts have proposed even more radical solutions, from separate parachute systems for the wing and fuselage to built-in aerodynamic brakes that can be activated at the moment of loss of thrust. At the time, it seemed like an extreme engineering flight of fancy. But years later, many similar concepts were reflected in the projects of promising small aircraft and experimental drones. To assess the realism of such engineering ideas, several scientific centers conducted simulations of the Concorde disaster. Various improvements were taken into account in these models. Extended stripes, EMAS zones, parachute braking systems, even a modified layout of fuel tanks. And the results were shocking. In dozens of simulations, the probability of saving the lives of passengers and crew reached 75 to 90% if Concorde could safely stop or quickly slow down at the moment of a tire rupture. The variants where the aircraft remained at the airfield turned out to be especially effective, rather than trying to break away in conditions of loss of thrust with one jammed landing gear. The engineers emphasized that it was impossible to say that these solutions would have guaranteed salvation. But the model clearly showed that the liner would have had a chance. And sometimes a chance is all that's missing. Concorde has become not just an object of investigation, but a catalyst for a global rethink. After him, the aviation engineering community saw that even the most advanced machines can become vulnerable where no one expects. Solutions that were considered theoretical suddenly became practical, and airfields around the world began to implement new standards. But the most important thing is the changes that would have saved Concorde if they had been introduced earlier. When the investigation was completed and the conclusions were formed, other work began. Much quieter, but no less important. Air France and British Airways engineers, together with the Concorde manufacturing teams, have begun a deep modernization of the aircraft. Their task was to make the liner resistant to those factors that normally seemed unlikely. The first step was to strengthen the fuel tanks. Kevlar linings were installed on the inner surfaces, multi-layer panels made of heavy-duty synthetic fiber. Kevlar is a material used in body armor. It does not break or tear from shock loads. His task in the Concorde wing was simple: to absorb the energy of a possible impact to prevent a fuel tank breakdown. Now, even a large fragment of a tire would not be able to destroy the structure so easily. Then there are the new Michelin heavy-duty tires, designed to take into account the extreme loads during takeoff of a supersonic airliner. These tires had a reinforced cord, additional layered reinforcement and protection from flying fragments in case of damage. If such a tire had been on Flight 4590, the rupture could have been local, without the release of massive parts that turned into a projectile that July evening. We also updated the wiring and hydraulic lines, replacing them with materials resistant to high temperatures. The areas adjacent to the fuel tanks received additional protection from thermal effects. This reduced the risk of fuel leakage and critical heating in case of unforeseen damage to the wing. The work was done quickly, almost swiftly for aviation standards. And already in 2001, Concorde returned to the sky. The first flight after the modernization was an event, not only engineering but also emotional. Spectators from different countries gathered on the platforms to see the legend rise again. When the nose of the car tilted smoothly down before takeoff and then rose into the sky, it seemed that the era of supersonic would continue. But the world has changed, and not only because of the tragedy of Flight 4590. By the early 2000s, the aviation industry had entered a period when speed was no longer the main argument. People flew more often, but they weren't looking for supersonic flights but affordable tickets. Concorde was a beautiful symbol, but expensive and difficult to maintain. Its engines consumed huge amounts of fuel. Maintenance required a separate engineering team, and regular flights needed special airport conditions. After the upgrade, the operating costs increased even more. Kevlar panels, new tires, updated safety systems. All this increased the cost of every hour in the air, and demand has dropped. Many passengers preferred economical flights, and companies reduced costs in the face of global changes. And in 2003, two Concorde operators, British Airways and Air France, announced the end of the program. The decision was pragmatic. An expensive liner, limited demand, high maintenance costs, and increasing demands on the environmental friendliness of jet engines. Concorde's last flight was both a triumph and a farewell. Along the runways, people stood with cameras, some with flags, others just watched in silence as the white arrow rose into the sky for the last time. When he turned around on his final course and disappeared over the horizon, many said, "We'll never see anything like this again." Technological progress sometimes moves forward, leaving behind machines that were ahead of their time. Concorde became just such a machine, an idea that proved that a person can fly faster than sound in civil aviation, but at the same time could not withstand the pressure of the economy. That's how the era ended, but the legend remained. When talking about Concorde, one rarely remembers the subtle engineering drawings, tire pressure, or skin temperature. All of this is important, but that's not what created the legend. Concorde became a symbol of the era not because it was the fastest, but because it embodied humanity's desire to go beyond the limits of what is possible. He wasn't just a machine, he was a promise, a reminder of a time when people built not for profit, but for the sake of the future. When engineers tried to surpass the nature of speed, and countries created joint projects that seemed too expensive and too daring to be real. Concorde proved that if you combine ambition and knowledge, then even the sky does not become a high enough limit. Those who flew on it remembered not the service, not the menu, not the photos at the ramp. They recalled the moment when the liner broke through the wall of sound. At that moment, the vibration left the hull, the noise disappeared, and the passengers found themselves as if in another dimension, in a thin layer of the atmosphere, where the Earth seems far away and time is flexible. It was a feeling that could not be expressed in numbers. When talking about supersonics, many people uttered almost the same phrase, as if quoting each other. Once we flew faster than sound, and there was a slight sadness in those words. Not that Concorde is gone, and the fact that with him went the courage of that era, a time when technology was not just becoming more complicated, but amazing. When air travel was not a daily necessity, but an event that was expected. When the very idea of speed seemed like a part of a dream, rather than a line in the characteristics. Today, when people review old Concorde videos, they don't see the outdated aircraft. They see a white arrow that flew where even military vehicles were working at their limit. They see a project that has become futurism even before the advent of smartphones, the internet, and new aviation materials. They see how a group of engineers was able to create an airliner that outstripped the rotation of the planet. Concorde has gone down in history, but it has not disappeared. It became a reminder of what progress can be like if it is born not of budget figures, but of a desire to rewrite the boundaries of what is possible. And maybe one day the world will create a passenger plane again that will fly faster than sound. Perhaps new technologies will make it safer, cheaper, and more environmentally friendly. But even if this happens, Concorde will remain the first. By doing so, a legend who pierced the sky and changed the way we look at flying. He became more than an airplane. He became a story that lives not in museums, but in the memory of those who saw him in the sky, who heard his roar, who felt the vibration of the air when he flipped through the clouds like the pages of a book. Speed is just numbers, but what Concorde has left in our memory is eternity.